Yes po, ma'am.
Yes po, ma'am. Good morning po.
Yeah, good morning. So this will be your first lesson for the midterm, and I've already checked last Sunday your prelim exam. After my classes, after your section, kasi may kasunod kayo after this, may kasunod kayong section sa akin, I will return your prelim exam, ha? And the results are very good. There are some of you who got it perfect and most of you got it line of 6. Line of 6, 60 plus over 70 and it's good. Okay? I'm still waiting for your grades in your laboratory. So anyway, the dean have not yet required for your grades yet. Okay? Ay, sandali si Edson. Okay. So I will start my screen sharing now. Ayaw lumabas. Ayun. Can you see my screen now?
Yes po, ma'am.
Okay. So this is your midterm lecture, the first lesson in your midterm lecture where we will be applying what you have learned in your module 4, naming and writing chemical formulas. Okay. So in chemical reactions and balancing chemical equations, you have the option to write your solutions, but this presentation shows solutions. There are some students who can balance chemical equations by inspection, just by looking at them. Okay. So for this module class, you should be able to identify and derive chemical equations from descriptions of chemical reactions, meaning from the names, you should be able to write their formulas as a chemical equation. Then after writing your chemical equation, you should be able to balance it. Then also, you would be able to predict the products of a chemical reaction. So when you say chemical reaction class, it is a shorthand way of writing transformation. If you recall, chemistry is defined as one of its definition is the transformation of matter. So it happens through chemical reactions. If you will look at this first example, carbon and oxygen, it yields carbon dioxide. So we read the arrow as yields. Those on the left side is your, ay, sino yun? Okay. So on the left side are your reactants. Then on the right side is your product. Okay. Then another way of writing chemical reactions, they may indicate the state or phase of your reactants and your product, such as this. Your carbon with enclosed in parenthesis S means it is solid. Then your oxygen and carbon dioxide with enclosed parenthesis G means they are in gaseous form. Then also, what you would be doing, what you should be able to do after this module is this type, where you can balance them. As you can see, there are already coefficients and also in some equations, there may be symbols on top of your arrows. So they can be either catalyst or inhibitors. But in this reaction, the triangle there indicates heat. It means the heat speeds up this reaction. As you can see here, CH4, that is methane gas, and 2 moles of oxygen in gas form, it yields carbon dioxide gas and 2 moles of water vapor. Water vapor because water is in gaseous form in this chemical equation. Another way of writing chemical reactions have these forward and backward half arrows. These forward and backward half arrows is read as a reversible reaction or an equilibrium reaction. When you say equilibrium reaction, it means the rate or speed at which your products are formed is the same as the rate on how your reactants will be formed. So, if here in this two half arrows, if the arrow going to the right is shorter compared with the one going to the left, it means your formation of products is slower compared with the formation of your reactants. But in these half arrows, if the arrow pointing to the left is shorter compared with the one pointing to the right, it means your formation of reactants is slower compared with the formation of your products. Okay. Sino yun? Hey. Hmm? Ba, himala, umatind. Okay. So, we try to balance these chemical reactions, class. The numerical coefficients that you can see is read as 2 moles, as you can see in this reaction. Okay. So we first do your balancing of chemical reactions. Class, there are some exceptions when writing your chemical reactions, and these are some of them. These diatomic elements are elements that occur as two atoms in nature per one molecule. So it means when you write them in a chemical reaction, you don't just write H. You write them with subscript 2. So what are those diatomic elements? They are your hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. So these diatomic elements, as you can see in this chemical reaction, they have subscript 2. So the first chemical reaction that we will be balancing will be the reaction between nitrogen and hydrogen. So nitrogen and hydrogen gas, they yield ammonia. Sino yun? Aba, nagbagong buhay. Okay. Okay, so NH3 class is ammonia. This is how to solve it, but class, you have the option if you still want to show your solution or you do it by inspection. So we first count in balancing chemical reactions, we count the number of atoms in the reaction and make them equal. The reason for this is like what we have learned in your module 4, it is for the law of conservation of mass. Ideally, mass of reactants should be equal to mass of your products. So in this equation, your nitrogen has 2 atoms and hydrogen has 2 atoms. On the product side, nitrogen has 1 atom and hydrogen has 3 atoms. So as you can see, there are an equal number of atoms on both sides. So to make them equal, we put a multiplier. We multiply by 2 your 1 atom of nitrogen on the product side to make it 2 atoms. Where will you put your multiplier? You put it in front of the compound or the element where your multiplier was used. So here it is in ammonia. But when you put that multiplier as a coefficient in your ammonia, it will also affect the number of atoms of your hydrogen. So it means here that your 3 atoms of hydrogen will also be multiplied by 2 and you will have 6 atoms. But if you will look on the reactant side, there are only 2 atoms of hydrogen. So how do we make it 6? We multiply it by 3 so that there will be 6 atoms. So where will we put the 3 that we used as a multiplier? You put it in front of the element where you multiplied it with. So please look again in this equation. 2 atoms of nitrogen on both reactant and product side, then 6 atoms of hydrogen on both reactant and product sides. So the numbers that you have put in front of the elements and the compounds in your chemical reaction will be read as 3 moles and 2 moles. So it means in this balanced chemical reaction, it will be read as 1 mole of nitrogen and 3 moles of hydrogen yields 2 moles of ammonia. For the second reaction that we will be balancing, we will again make use of diatomic elements. So this time, it will be water. So for water class, it separates into hydrogen and oxygen gases. So as you can see here, if we will count the number of atoms on both sides, your hydrogen in your reactant side has 2 atoms and the oxygen has only 1 atom. On the product side, there are 2 atoms of hydrogen and 2 atoms of oxygen. So as you can see, we have to make the number of oxygen atoms equal. So we multiply the oxygen atom by 2 so that we will have 2 atoms. Where will you put the multiplier? You put it in front of the compound where your oxygen is included. So we put it in front of water. But as you can see, class, when you put it in front of water, it will also affect the number of atoms of hydrogen. It means your hydrogen will also be multiplied by 2 and you will have 4 atoms. But if you will look on the product side, there are only two atoms of hydrogen. So we multiply it by 2, so it will also be 4 atoms. And that multiplier, we put it in front of the element so that it will also be 4 atoms. So please look again. Both sides have 4 atoms of hydrogen and both sides have 2 atoms of oxygen. So those numbers you used as coefficients that you put in front of your compound and element will be read as 2 moles. So this balanced chemical reaction will be read as 2 moles of water yields 2 moles of hydrogen and 1 mole of oxygen. Okay. For our third example class, we recall your module 4. In your module 4, what we did, we formed compounds from binary ionic compounds and transition metal ionic compounds. When you say ionic compounds, we do crisscross method for your cations or the positively charged ions and your anions or the negatively charged ions. So if you will look at this reaction, nickel and hydrochloric acid, it yields nickel chloride and nickel 2 chloride and hydrogen gas. So please look above class. Your hydrogen chloride or hydrochloric acid, it was formed from your cation hydrogen, which is positive 1, and your anion chloride, which is negative 1. By crisscross method, hydrogen will take 1, chloride will take 1 from hydrogen. Since they are both positive negative 1 in charge, you will not write any subscript. But if you will look at nickel 2 chloride, the nickel that we use this here, it is a transition metal. So the nickel cation we used here is nickel positive 2. So as you can see in nickel 2 chloride, nickel will take 1 from chloride, while your chloride will take the 2 charge coming from nickel. So you write it as a subscript after doing your crisscross method. Now for the elements class in a reaction, your nickel and hydrogen gas, as you can see, nickel, when it is alone, it has zero charge. Then also your diatomic element, hydrogen gas, when it is not in compound form, its charge is also zero. So when we balance this, we can show the solution. We write down the elements on both sides. In the reactant side, nickel has 1 atom, your hydrogen has 1 atom, and your chlorine has 1 atom. While for your product side, nickel has 1 atom, hydrogen has 2 atoms because it is a diatomic element. Remember, when these gases are alone, you have to write subscript 2. Then your chlorine has 2 atoms. So we need to make the number of atoms for each element equal. So we multiply hydrogen by 2 first, so there will be 2 atoms. The multiplier, we put it in front of the compound containing hydrogen. So we put it in front of hydrochloric acid. But as you can see, when you put it in front of your hydrochloric acid, it will also affect the number of atoms of your chlorine. So it means your chlorine will also be multiplied by 2. So there will be 2 atoms. So as you can see here, the 2 that you wrote in front of hydrochloric acid or hydrogen chloride will be read as 2 moles. So if you will check in this reaction, both sides have 1 atom of nickel each. Then your reactant and product side have both 2 atoms of hydrogen and 2 atoms of chlorine. So this balanced chemical reaction, if we will be reading it, it will be read as 1 mole of nickel and 2 moles of hydrochloric acid yields 1 mole of nickel 2 chloride and 1 mole of hydrogen gas. In real life class, this occurs as corrosion. It means your nickel will corrode in the presence of your acid, and your nickel 2 chloride as a product will form as a coating as rust on your metal, and some of them will form as precipitate, and they are your products already, your nickel 2 chloride. And then the hydrogen gas, you will see it as bubbles while it is reacting. Yan. So we apply again class your lesson last module 4. In this situation, we will be using your polyatomic anions. So what we used, aluminum and copper 2 sulfate. So copper 2, because copper is a transitional metal, it is positive 2 and positive 1, we used in this reaction copper, which is positive 2. Then your sulfate as a polyatomic anion contains sulfur and oxygen as a group. And as a group, the whole sulfate ion has a charge of negative 2. So when your aluminum and copper sulfate react with each other, they will yield aluminum sulfate and copper metal. So as you can see, your aluminum sulfate, please look on top, it is formed from aluminum, which is positive 3 because aluminum belongs in family 3A. Then your sulfate as a group as negative 2. Crisscross method, aluminum will take the 2 from sulfate, and your sulfate as a group, that's why you have to enclose it in a parenthesis, will take the 3 coming from your aluminum. Then if you will look on the reactant side, we did not put any parenthesis or write any subscript. That is because both your copper and your sulfate ions are charged with 2. So if we start balancing them, your aluminum has 1 atom, your copper has 1 atom, and your sulfate as a group, that's why you are allowed to use your periodic table, you have 1 group. If there is no parenthesis, it means your sulfate is 1 group. On the product side, aluminum has 2 atoms, as you can see, because it is Al2. Then, your copper has 1 atom, and your sulfate, they are 3 groups coming from your parentheses, then 3. So we balance first your aluminum. We multiply it by 2 so that there will be 2 atoms. The multiplier you put in front of aluminum. Then, it is read as 2 moles. For your sulfate group, we multiply it by 3 so that there will be 3 groups. Then, we put it, the 3, as a multiplier, we put it in front of the compound containing your sulfate group. But as you can see here in the reactant side, when you put it in front of copper 2 sulfate, it will also affect the number of copper atoms. So it means your copper will also be multiplied by 3 and there will be 3 atoms. So if you will look on the other side, on the product side, we multiply copper by 3 so that there will be 3 atoms also. Okay? So please check again. 2 atoms of aluminum, both on the reactant and product sides. Then 3 atoms of copper, reactant and product side. And 3 groups of sulfate, reactant and product sides. So those that we put as coefficients when we multiplied them, they will be read as 2 moles of aluminum and 3 moles of copper 2 sulfate yields 1 mole of aluminum sulfate and 3 moles of copper. And if you recall, class, when an element is alone, its oxidation state is 0. Unlike in compound form, as you can see on top, the oxidation state or charge of copper is positive 2 and sulfate is negative 2, and aluminum is positive 3 and sulfate is negative 2. But your aluminum on the reactant side is 0 charge, and the copper on the product side is 0 charge. Yan. So this reaction class that we will be balancing is composed of 2 compounds on the reactant side. So the first reactant is magnesium phosphate. As you can see on top, it is formed from magnesium positive 2 because magnesium is from family 2A, and your phosphate group, if you will refer in your periodic table, it is negative 3. By criss-cross method, we form your magnesium sulfate where magnesium will get 3 from phosphate, and phosphate having 2 elements, you enclose in a parenthesis, and that as a group will take 2 from magnesium. And we have to write it as subscript. Your sulfuric acid is formed from your sulfate anion, which is negative 2 as a group, and your hydrogen, which is positive 1. By criss-cross method, your hydrogen will take 2 from your sulfate, and your sulfate will take 1. But of course, since that is 1, we don't need to write parenthesis 1. So when these two compounds react with each other, it will form magnesium sulfate and phosphoric acid or hydrogen phosphate. So as you can see, in your magnesium sulfate, we did not write any parentheses or subscript because both of them have 2 as their charges. Magnesium is positive 2, while your sulfate as a group is negative 2. For your phosphoric acid, as we have seen in magnesium phosphate, your phosphate has a charge of negative 3 and hydrogen has a charge of positive 1. By criss-cross method, hydrogen will take the charge of 3 coming from phosphate group, and phosphate will take 1 from your hydrogen. So we try balancing them. Your magnesium, from the subscript 3, there are 3 atoms. Your phosphate, since it is enclosed in parentheses and 2, it means 2 groups. Your hydrogen, with a subscript 2, means it has 2 atoms. And your sulfate, having no parentheses, means it is 1 group. On the product side, magnesium has 1 atom. Phosphate is 1 group because there's no parentheses. Hydrogen has 3 atoms because, as you can see, it has a subscript 3. And sulfate will exist as 1 group because there's no parentheses and a subscript. So to make both sides equal, we multiply magnesium by 3 so that there will be 3 atoms. The multiplier, we write it in front of magnesium sulfate because that is where your magnesium is contained. But as you can see, when we put it in front of your magnesium sulfate, it will also affect the number of your sulfate groups. So it means there will be also 3 groups of your sulfate anion on the product side. So it means on the reactant side, to make it equal, we have to multiply your sulfate group by 3 so that there will be 3 groups. And we put it in front, that multiplier 3, we put it in front of your sulfuric acid because that is where your sulfate group is. But as you can see, if you put it in front of your sulfuric acid, it will also affect the number of atoms of hydrogen. So it will be 3 that you will be multiplying with your hydrogen, and there will be 6 atoms. If you will look on the reactants, on the product side, there are only 3 atoms of hydrogen. But on your reactant side, there are already 6. So to make it 6, we need to multiply it by 2. So there will be 6 atoms also. The 2, we use it as a coefficient in front of your phosphoric acid. But when you put it in front of phosphoric acid, it will affect the number of phosphate groups. So it will become 2 groups of phosphate. So please check the reaction. Both sides have 3 atoms of magnesium each. Then, reactant and product sides both have 2 groups of phosphate, 6 atoms of hydrogen, both sides, and 3 groups of sulfate. So, as you recall a while ago, every time we multiply, we put those multipliers, we put them as your coefficients in front of the compounds or elements where they belong. So, your balanced chemical reaction will be read as 1 mole of magnesium phosphate and 3 moles of sulfuric acid yields 3 moles of magnesium sulfate and 2 moles of phosphoric acid. Wait lang muna, class, ha?
Pwede po magtanong.
Yes.
Um,
Onsay.
yes po, question po.
Yeah.
Pwede po ba hindi na po gumamit ng groups? Pwede po, di ba?
By elements.
Yes, by elements na
Okay.
lang para po atoms lang.
Oo, kung iyon ang mas madali sa'yo.
Okay
Okay?
po.
Kasi
Thank you.
kasi if you do it by elements, you will still arrive at the same coefficients rin naman.
Yes po.
Mm.
Okay.
Yun ang kagandahan sa science, only one final answer, whatever is your solution. Math and science, ha? O,
Thank you
yan.
po, ma'am.
Mm-mm. Okay, so after we balance the chemical reactions class, we should be able to identify what type they are. Okay, so there are 4 types of chemical reactions as you will see here. So if you recall, our first chemical reaction was this: nitrogen gas and 3 moles of hydrogen, it yields 2 moles of ammonia. As you can see, nitrogen and hydrogen gas, they just combined to form ammonia. So this type of chemical reaction is a synthesis or combination reaction. It means, class, when two elements are combined to form a product, that is synthesis or combination. Then the other example that we used, 2 moles of water yields 2 moles of hydrogen gas and 1 mole of oxygen gas. As you can see, your water has separated or decomposed into its components, hydrogen and oxygen gases. This reaction, class, this is called hydrolysis. If you this is called electrolysis. If you recall, there were news before that water can be used as an energy source. It is because of this reaction, the production of hydrogen from electrolysis of water, where there is electricity that passes through water and it separates into its component, hydrogen and oxygen gases. Other advanced countries like Japan and Germany, they have fuel cells that employ this type of reaction as its energy source, as their battery. So as you can see, since water broke down into hydrogen and oxygen, which are its components, it is called decomposition. Okay. Then for the third type of chemical reaction, our equation that we have balanced a while ago, 2 moles of aluminum and 3 moles of copper 2 sulfate, it yields aluminum sulfate and 3 moles of copper. So please observe here, class, that on both sides, in the reactant side, you have one element and one compound. Then on your product side, you also have one compound and one element. In this type of reaction, class, we consider the activity series. So as you go higher, the activity series, you are the more active metal. And if we will observe in this activity series, aluminum is higher compared with copper. It means aluminum is a more active metal compared with your copper. And what does this activity series tell you? It tells you that aluminum can replace copper in copper 2 sulfate. So when aluminum replaces copper in copper 2 sulfate, it will form your aluminum sulfate, and the copper that was replaced will exist as a solo element in your product side, as you can see on the right side. So when this occurs, the replacement of your cations, this type of reaction is a single replacement reaction. Why single replacement reaction? Because You have an element and a compound, and since one of your cations is more active than the other cation, it will form also another compound and the displaced element. So this is SRR, or single replacement reaction. For the fourth type of chemical reaction, please look class. So magnesium phosphate and 3 moles of sulfuric acid, it yields 3 moles of magnesium sulfate and 2 moles of phosphoric acid. Please observe both on the left side, reactant side, and on the right side or product side, both of them are composed of compounds. So we refer again to your activity series. So in this activity series, as you go higher, please observe class, why is gold an expensive metal? Because it is the one that does not corrode easily, being located on the lower part of your activity series. So if you will observe, magnesium is on the higher part of the activity series compared with hydrogen. So this means your magnesium can replace hydrogen in your sulfuric acid. But since both of them will come from compounds, they will also form two compounds. Unlike in the previous example that we had, where the element was just displaced, there will be an exchange in this reaction. There will be an exchange of cations, but two compounds will be formed. So when magnesium in magnesium phosphate replaces hydrogen in your sulfuric acid, it will form your magnesium sulfate. And the hydrogen from your sulfuric acid will combine with, ayan ha, magnesium will replace your hydrogen in your sulfuric acid. So this hydrogen, when it is displaced, it will combine with your phosphate. So it will form your phosphoric acid. And since there are two compounds that were formed, walang naiwan mag-isa. So this is a double replacement reaction, DRR, or you may call it as a double decomposition reaction, or you may call it as a metathesis reaction. So please recall, if you have an element and a compound that forms another compound and the element that was replaced, that is a single replacement reaction. But here in your but here in your double replacement reaction, though there will be replacement of your cations, there are two compounds that will be formed. Okay? No element was left alone. That's why it is a double replacement reaction. Okay? So I will upload your module 5 and then you will be doing your exercise. Lumabas pa siya. And you will be doing your exercise 9. After my class, after your section, I will return your prelim exam. Okay? And also for the next meeting class, please bring your calculator and periodic table of elements next class meeting.